Chinese medical textbook, and they just illustrate what is the schizophrenia and what is bipolar disorders. So these are all pattern recognitions. I think almost every medical doctors are doctors with patterns. And there's a book called Deep Medicine, which is written by the Dr. Topo in the United States. They divide the doctor into two types, which is doctor with patterns, like a radiologist or pathologist. They look at images. And also there are doctors without patterns, like for internist, like a psychiatrist, something. But I don't agree with that concept, because I think every doctors, actually, they always look at some patterns. For example, in the hospital, when we look at patients, we try to collect information and we try to differentiate the patterns from patterns and to make a diagnosis. So these patterns can be very abstract, where maybe just like the symptoms, and also it's a pattern. And we need some technology to identify patterns. For example, 100 years ago, this is the first ECG machine, electrocardiogram, in the world. And the inventor is Dr. Einthoven. So you can see that now we can make an ECG device very small, but in the beginning, the device is very big, just like MRI machine or like chest X-ray machine is also very big in the first time. But with this device, now we can identify different type of arrhythmia, 心律不整. So we try to recognize these patterns and to make a diagnosis. So that's why I said the medicine is a pattern recognition science. The X-ray is also one important technology. So with X-ray, we can look through the human body without just cut into the body. So that's a very important progress. So today I will show you how to read this, the pneumonia, the chest X-ray images. Okay. And also the DNA is also another big advance in the medical field, because with the DNA codes, then we can identify genetic disorders. So this is also a pattern recognition in the medical field. So nowadays, in the hospital, we have lots of information. We have ECG, we have laboratory data, we have a symptom profile, we have X-ray, we have a microscope, and we also have like a stethoscope. We can see, hear the heart sound, and other things. So this is all this information. We use our brain as an AI system to make a diagnosis and do some evaluations. And with the development of computers, we now can digitize everything. Okay, so the digitalization, I think, is the first step of intelligent healthcare. So now we can digitize the X-ray images. And we can also digitize the ECG signals. And virtually, we can digitize everything, like electronic patient record, and also like even the voice, even the brain images, they are all digitized. So with these technologies, we have lots of information. So in the past, we can just use our pen and to write the diagnosis and symptoms. But now we just use computers to record everything. And this will make the healthcare data ocean. So there are different types. For example, in Taiwan, from the 1996, we have a national healthcare system, and we record every visit of hospital. So that's the big data, health insurance, the claim data. And also, for each hospital, when we develop the electronic medical record, then we will have lots of electronic medical record data. And also, in the intensive care unit, we use lots of monitors to record the patient's the signals and physiological conditions. And also, for the clinical trials, we have lots of the drug data. So, for example, we will record whether or not the patient will have adverse effect when they're receiving a new drug. So this is also a very important data source. And also, for example, imaging data is one of the big data, and also the genetic data. About like 10 years ago, when you want to do the whole genome sequencing, it will cost you like 10,000 US dollars. But now you can just spend like 1,000 US dollars to do the whole genome sequencing. So the cost has been reduced significantly in recent years. And with the whole genome data, then we can try to figure out many diseases and their mechanisms. So do anyone know how many base pairs in our DNA codes? Any ideas? How many base pairs in our DNA codes? No, it's about 3 billion base pairs. Okay, so it's a huge data. So you can look out into the PubMed and try to find many whole genome sequence on the data. The data is very big. So even for one person, you need like 1 gigabyte to store this kind of data. So I would imagine in the future, the doctors will be overwhelmed by the lots of the medical informations. So this is one of the scenario that maybe in the future we need to look at many monitors in our clinics. Actually, nowadays, in reality, we already have lots of the applications in our computers in the hospital. For example, in the Taipei Veterans General Hospital, in the clinical computers, we have medical chart applications. We also have like imaging PACS applications. And we also have some application can access to ICU data. So maybe in the future, this is the reality. We just need many monitors to do this. And also, so you can imagine that the data size will accumulate in a very astonishing way. So, for example, in the 2013, the healthcare data is estimated to like 153 exabytes, and 1 exabyte is equivalent to 1 billion gigabytes. And for many computers, like the computer I use here, we have only like 512 gigabytes, the hard drive, the drive size. When the 1 exabyte is 1 billion gigabytes. And now, this year, it's about 2,314 exabytes. So this is very big data. But we need to know that not every part of the data is important or useful. I just use sleep study as one example. So if we want to diagnose sleep problems, we need to do the sleep study at hospital, and patient need to sleep overnight in the hospital. And we will install the many sensors on the patient, for example, the electroencephalogram, the brain wave. We also need to record the muscle activities. We need to record the nasal airflow. We need to record the ECG, need to record the blood oxygen level. We also need to record the body positions. So there are many sensors in the sleep studies, but not all of them are important. For example, if you want to identify whether or not patient is in the dreaming state, which is called the rapid eye movement stage, then you just look at the EOG data, which is the muscle activity around the eyes. And you will see this kind of pattern will say, okay, this is the REM stage. But for other pattern, for example, the patient may stop breathing. So you may heard about the 呼吸中止症, the obstructive sleep apnea syndrome. So we can identify if the breathing is stopped during the sleep. So you can see that there are lots of information in this, even like 30 seconds the page, but only this part is important. But we need to find a way to identify this part, but not the other part. So that's the tricky, very challenging task. So use this example to show what's the concept behind this. So we have the big data, but only part of that has information. And with these small pieces of pizza, only part of this slice is very crispy and tasty. So that is the most important information. Only stands very small parts of the whole big data. So that's why we need AI and artificial intelligence algorithm. Because in the past, we can use our brain to read through all information to formulate our diagnosis. But now we just be overwhelmed by this kind of data, so we need AI. And the AI is not just, we don't need the fancy AI to do this. So for example, in 2017, there's a paper, very interesting paper, show you how you can just using Google imaging search to do the medical diagnosis. For example, everybody knows that Google has a very useful web search and imaging search platform. So they just upload the image, the pathology image, like one is benign, and the other is a tumor, a cancer image, and see how many images returned by Google is also benign or is cancer. So they found that if they upload the cancer images, and they found that 50% of the Google images return results are also cancers. Meaning that Google can just try to compare the patterns between images and return the 50% of them are correct. And if you upload the benign images, then the 83% of results are also benign images. So this is very interesting because it just shows you very interesting ideas that AI is just pattern recognition. So you don't need a very fancy algorithm to do AI. So all you want to do is just do the pattern recognitions in this kind of data. So if you accept these ideas, then you will understand the AI, what AI do. So AI can try to detect the cancer patterns in pathology image. This is no problem. And also there has been many companies try to develop the digital pathology applications. For example, in the past we used microscope to look at the pathology images, slides. But now we can just scan these slides into the digital images and try to label the cancers, the cells with the cancer formations. And also, for example, now it's like a coronavirus epidemics. So everyone wants to know if a patient comes to hospital if they have a pneumonia. But if one has a pneumonia, you need to do chest X-ray. And it's actually very challenging to diagnose pneumonia on the chest X-ray. Sometimes it's very easy, but sometimes it's very hard. For example, if a pneumonia is behind the heart, then it's very difficult to diagnose. You need to look at the patterns. If pneumonia is in the left or right side, then sometimes it's easier. So there's a chest X-net developed by Stanford University. They try to collect lots of chest X-ray data. And they have published papers that showing that the AI algorithm is already superior to the doctors at the detection rate of the pneumonia. But you may ask them why still no people using this in the hospital. That is a big question. If we have a good AI system, why don't we just use this kind of system in the hospital? So I also try to ask this to many people, but the one issue is that we still rely on the human judgment. And also this is by law, by regulations, we need to report our diagnosis by human, not by machine. So that is the big hurdle that, to implement this kind of system into the hospital. But anyway, there are many other applications. For example, AI can help you to detect the fractures. Okay, and also in the psychiatry, AI can help us to read the moods based on the face. This is very intuitive because when we talk to patients, we know the patient is not in a good mood because just based on the sad face. So this is the one important applications. And also for the imaging, then we can also, in the ophthalmology, they have lots of the new technologies to diagnose the eye pathology. For example, the diabetic neuropathy, or using a different kind of modality, like these fundus examinations or the OCT. So this is new development. Also the dermatology, 皮肤科, they also have already developed many applications to detect the skin problems. So, so this is the fancy chart. Just show you that the AI application approved by the US FDA since the 2014 September. So you can see that there are many applications, but on the right side, they categorize into the different medical fields. For example, you can see that the big cluster is in the radiology. So it's not surprising because the radiology is based on imaging. And also the endocrinology and psychiatry. So psychiatry has also many AI applications. And cardiology, 心脏科. Okay, so I think I know some of them don't know the medical terms. So this is using Chinese 心脏科、精神科、内分泌科、放射科 ，and this is 老人医学科、神经科，这是骨科，然后急诊然后再是这眼科、病理科跟肿瘤医学科。So this covers almost every aspect of the medical fields in the hospital. So I already showed you the first part is digitalization, and the second part is AI algorithm. But I think the most important part is the clinical workflow. So when you want to implement an AI algorithm in the hospital, you really need to convince doctors and medical staffs to use this algorithm, right? So let's see what's the workflow in the hospital. The patient might feel sick, so they will went to hospitals. And so in the reception desk, we will try to register patients and to give them a number. And we also want to pull up all the data about these patients. And we will present these patients to the doctors. And the doctors will try to organize this data and try to collect new information about the patient and to make a diagnosis and also the judgment. And for these judgment plans, then you will try to do some examinations or to receive some treatment. But also, the patient also wants to pay some money to the hospital. So we have also finance department to collect money. And also, we hope that patient will recover from the sick status. So this is the typical workflow in the hospital. And the question is that, how can we incorporate AI algorithm into this workflow? So that's why for intelligent healthcare, we have many things to do. For example, can we collect these symptoms in an intelligent way? So a patient can, for example, just like in the morning we have a lecture that our lecturer says that in the hospital, patients don't know which specialty you want to visit when you have symptoms. So we need an AI applications to try to triage the symptoms and try to send patient to the right specialty. And for this part, we need a very efficient way to collect all the patient's data and into the doctor's office. And in this part, we need AI algorithm to organize this data and to try to help doctors to efficiently to make a diagnosis. And also, we need a very efficient AI algorithm to manage all all healthcare management in the hospital. So that's also a very important part. This is not easy. So I just show you one negative examples. For example, just in this January in this years, they have one paper in Nature to report that the international evaluation of the AI system for breast cancer screening. Okay, so now they use the big data to evaluate the AI algorithms. And they found that the AI algorithm can really reduce the workload of the radiologist. So that's one incentive that we use the AI systems in the hospital. But if you can reduce the workload of the radiologist, is that just enough? That is the question. Because following this article, there are already many comments that against this kind of ideas. Because for the breast cancer screening, we already know that the mammography, which is the X-ray images of the breast, they already have lots of the findings can be proven to be false positive. So even AI can find out all pathologies based on just the mammography, and the patient might don't need to do anything. For some lesions, they are benign, so they don't need to do anything. They just need to do follow-up studies. And so only a few portion of the patient require the further management. So we need to ask ourselves that is artificial intelligence useful in this case? Because you can imagine many of these cases will be not just false alarm. So that's why even the AI has a very high accuracy in detecting lesions, but in the workflow, we do not really need this kind of algorithm to do every procedures. So I just use this example. For example, in when the patient do find out their lesion in the lung, they might want to do some biopsy surgery to see what this lesion is the malignant or the benign. And we will put on this biopsy tissue on the slides. And doctors, pathologists will need to read these slides and to see if this is benign or not. So this whole process, of course, we can digitize every process. And of course, we can develop AI algorithm to help doctors to identify the cancer cell. But it's not really efficient, and also the cost will be acceptable. That is the question. But anyway, there has already been many companies like this PathAI.com. These companies in Boston. So they already developed an AI algorithm to do these kind of things. And their ideas is that we can accelerate the diagnosis process. And also we